Okay, so today we are going to cover ratios and we'll see if time permits, we will go to proportions and we might go to rates as well. Right. Let's see how the speed of the session goes. Right. But this is a very, very important and a common topic that holds very, very great importance in our daily lives and obviously in schools as well. So let's get rocking. I know a lot of you might know this, but there are nitty-gritties that we are going to touch today. So if this topic is new to you, so please feel, make sure that you are listening properly, right? Without any chat distractions. And if you know this, probably a revision for you. And if you sort of know it, this is a brush up for you, right? As in, I'm just brushing it up, and then hence eventually a revision. Okay, so let's start with the word ratio. What is a ratio? Ratio is actually used, it is a way to compare quantities of same kind, quantities of same kind. Now, ratios in itself, they don't have any kind of units because we are measuring quantities of similar nature, all right? So if I have, let's say, fruits, so if I have two oranges and five apples, let's say they are being used to make some jelly or some pudding. So I hope people can see what I'm writing. Yes or no? Can I quickly? Because there are a few people who said that they can't. People can see what I'm writing, right? No. Okay. Hang on. Let me share my screen again. Just give me a sec, please. All right. I'll share my screen again, which is quite strange. Can you see now? Can anyone see now? Great. Not. I mean, I said at the beginning, right? Technology can trip you off. All right. So we were talking about ratios, right? So ratios are used to compare the quantities of similar nature, same kind. Now, if I'm saying I'm using two oranges and five apples to make a pudding, and I say what is the ratio? So I'll say 2:5. This is the symbol of ratio. A lot of old school, you know, parents, teachers also call 2:5 or 2:5. So it's is to 5:5 to ratio 5. So they are synonyms that we use to represent this mathematical symbol. Now, if I have two blue squares and three red squares, then my ratio is they're all at the end of the figures, right? Geometrical figures, something which is of the similar kind. So it is 2:3. 2 tells me the blue, whereas 3 tells me the red. 2:3. Okay, let's very, very basic, right? Very, very basic. I think most of you would know that. But still, if you don't know that, this is just sort of an introduction. Okay, one very important thing that we need to know is that the units of the ratios left figure and the right figure has to be equal, has to be the same. So if I say 10 seconds ratio 1 minute, then probably that is not the right units to form a ratio. They need to be of similar units. So either you convert seconds into minutes or you convert minutes into seconds. So the ratio here will be 10 seconds. Ratio 1 minute has 60 seconds. So it is 10 ratio 60, which is 1 ratio 6. So mind you, the units have to be the same in order to form any kind of ratio. Let's move ahead and go next step, right? There is a concept of, I'll not spend too much time on, this basic entity. I know a lot of you are year 7 and 8, so you would know this, right? Now, there's a concept of equivalent ratios. Now, what are equivalent ratios? The ratios which are equal ratios, ratios that are equal, that forms equivalent ratios. Now, let us say I have a ratio, or probably I want to make a concentrate, a cordial, which takes one part of the concentrate and four parts of water, four parts. And I make a 5-part cordial mixture. So the ratio here between the concentrate and the water is 1:4. 1 is the concentrate, 4 is water. Now let's say I want to make 10 parts of cordial now. What have I done? I have simply doubled it. I multiplied it by 2. Now, rather than 5 parts, I need 10 parts. So in order to find how much concentrate and water, I simply need to double their ratios. I times this by 2 and I times this by 2. So this becomes 2:8. And that'll make me 10 parts of cordial. Now, if you look at it, 1:4 and 2:8, they are called they're equal ratios, or hence I can call them as equivalent ratios, because I've found the highest common factor. I found that I'm multiplying my original ratio by the same number, both the sides, to generate a new ratio. So they are same. So 1:4 is equal to 2:8. So this is the concept of equivalent ratios, and hence This extends to something called simplifying or ratio in its simplest form. So simplifying a ratio, which essentially means that if I give you 2 ratio 8 and I ask you, can you simplify that? Yes. What you need to do is you need to find which is the number that divides both 2 and 8. Highest number, the highest common factor. So in this scenario, it is 2. So 2, so what I'm going to do is I'm going to divide this by 2, divide this by 2. And then I get 2 times 1 is 2 and 2 times 1 is 4. So my simplified ratio is 1:4. There are a lot of questions that are asked where you are asked to simplify a ratio or you have to simplify a ratio in order to get to the right answer. Very, very elementary stuff that I would just quickly ask you to do. Can you quickly simplify 16:24 for me? Please now, quick. Answer in the chat now. 16:24. Absolutely right. It is 2:3. So the highest common factor that I found was 8. Good job. And this was simple, right? I expect you to do all of this now. We've been together since last what? Almost more than close to a year now. One student, one answer is fine. Shaveen, you don't have to repeat it. Okay. I'll start calling out names now. Right. So 8 times 1 and 8 times 2. 8 times 1 and 8 times 3. So the ratio is 2:3. All right. Okay. Let's go next. 45 centimeter ratio 1.5 meter. Can you simplify that? Three ratio 10. Ishita, 3 ratio 10. Yes, 3 ratio 10 is the right answer. How did we do it? If I were to do it, I will simply convert meters into centimeters. Easier for me to deal with. No. So I'll simply say 1.5 times 100 makes it 150 centimeters. And then the job is simply to find the ratio, converting this into the simplest form. Right? 45 and 150. 15 is my common factor, my highest common factor, which means 3:10. Good job, everyone. This was easy. Now we can extend the concept of ratios to fractions. So fractions as ratios. No big difference between what we know today. Now let us say if I have a fraction on the left hand side as a ratio is 2 is to 5, ratio 7 is to 10. Now before I say, okay, we have to simplify this. So what we need to do here is we need to ensure that the denominators are same. The denominators are same. And there are two ways of doing it, right? And I'll tell you the simplest way. You need to think in such a way that how can I make them equal? How can I make 5 and 10 equal? The easiest way is if I multiply 5 by 2. So it makes it 10. But hang on, you have just touched the denominator of one of the fractions. You've multiplied it by a number. In this case, it is 2. So in order to maintain the equilibrium of the fraction, you need to do exactly the same thing at the top. So whatever you do at the bottom has to be repeated at the top and vice versa, so that the fraction remains the same. So eventually, this becomes 4 over 10 ratio 7 over 10. And if I really have to use a shortcut, my psychological shortcut, I would say 10 10 cancels. And hence, this becomes 4 ratio 7. With that thought in mind, if I may ask you to simplify this ratio, 5 over 6 ratio 5 over 8. Can you please simplify that? Take your time, there's no rush to the finish line. Answer has to be right. There are around 40 people out here, and one person needs to just answer once. Can I see all the 40 answers in case you're paying attention? Good job. Looks like this was easy. Anyone who hasn't got this, please feel free to write the answer once only. All right. Yes, 4 ratio 3. Now, how did we do it? How can I make 6 and 8 equal? So the best way is find its lowest common denominator, LCD. Or a lot of books says LCM, lowest common multiple. Yes, right. So you make it 24. What is the lowest common multiple that can make them equal? Which is 4. In this case, 6 times, this is 24. So you times 4 makes it 24. Times 3 makes it 24. But hang on, you've multiplied it here by 4. You do the same thing at the top. And you multiply here at the bottom as 3. You do it at the top. So now it becomes 20 over 24 ratio 15 over 24. And then your 24 cancels, because you can straight away knock off 24 as denominators. You're left with 20 ratio 15, which you can now simplify even further by dividing it by 5, which is their highest common factor, HCF. 5 times 1, 5 times 4, 5 times 1, 5 times 3. What? 4:3. And that is your answer. All right, a quick one. X over Y ratio A over B. Can you simplify this? I need everyone to see this answer, please. Okay, seeing sort of some answers. Might be right, might be wrong. I don't know. We'll give it a go. Okay, let's try to do this. Now, how can I make the denominators look the same? If I multiply this by b, it becomes by. And if I multiply this by y, it becomes by. I have multiplied the left fraction by b at the denominator. I have to do it on the top as well. And similarly, I've multiplied the right fraction's denominator by y. I have to do it on the top as well. So now I have bx over by ratio ay over by. By cancels. So you have bx ratio ay, or you can also write it xb ratio ya. The multiplication, all these, any of them. So this is the ratio way of. Is this clear now? What we've just done? I've not done anything different from what I just did here. Yeah, the previous example. They were numbers. That's about it. In this scenario, they were variables. So that tricked you. Or tricked you. A few of you got tricked. Right? Still remains the same. Okay. Now, ratios are nothing but they are fractions. They're nothing but they're fractions itself. So whenever I'm writing 2:5, it is actually 2/5. Remember that. Ratios are also represented as fractions and vice versa. Now, with that thought in mind, if I may ask you, just go a little fraction on the fractions. 2/5 over 3/7. Can you give me the final answer? How will my fraction look like? What's the final answer for this fraction? Anyone who don't know how to solve this can also say, I don't know. That's absolutely fine. I need to know how many of you don't know. 14/15 sounds convincing to me. Let's see how. Shavin, only one answer is fine. You are just you're just typing again and again and again. Last warning to you. All right. Now, few ways of doing it. Few ways of doing it. Let's do the ratio way of doing it. Let's do that. I told you that fractions can be represented as ratios. Hear me out loud and clear. Which essentially means that I can write this as 2/5, and this bit here is the ratio 3/7. I think you can do it now. Yes or no? Guys, people who said they don't know how to do it, can you do it now? You can. So, which essentially means there's no common multiple between 5 and 7. So, I have to just times here by 7, times here by 7, times here by 5, times here by 5. So, this becomes 14/35 ratio 15/35. And you can knock off this and becomes 14/15, which essentially means 14/15. Does that make sense, guys? Fractions and ratios they go hand in hand. They go hand in hand. All right, let's do one more and see if that makes sense to this. We'll do it, don't worry. First of all, till the time you don't have your right name on the chat, I mean, I don't know who this is, smile for the camera. I don't know. Put your right name and I'll start calling you. Okay? There's some rules of this session. Right? I've stopped taking questions from people who don't know the real names, right? The funny names. I'll try one, right? I still take you, right? That you did not get it. I'll take you, right? Okay, let's do one more. I have 2/7 over 1/3. Can you try that? Okay, let's do it, right? So people who did not understand, I'm just doing it, right? So be attentive and concentrate. Very, very simple. The first fraction is the left-hand side of the ratio. 2/7. This big division sign, this bit, is the ratio. 1/3. Now, the goal is just to convert this into a common denominator. What's the common multiple between 7 and 3? None. So I have to, which is 21. Sorry, not straightforward, it's 21. So I have to multiply here by 3, here by 7. So I'll repeat the same stuff. So this becomes 6/21 ratio 7/21. 21 cancels. 6/7. I hope this is clear now. Now, one more I mean, this was the ratio way of solving it. There's another shortcut, right? Without going through this that we've gone. There's another shortcut. I do that, Romilly. I don't go the ratio way since I was teaching ratio, so I thought, okay, let me teach you the ratio way. So I'll do the same question with my shortcut. So we had what? 2 over 7, 1 on 3. All right. 2 over 7 over 1 on 3. The, the denominator of the denominator gets multiplied with the numerator of the numerator. And the denominator of the numerator gets multiplied with the numerator of the denominator. I hope you got my English right. So now, what have I done? 2 multiplied by 3 over 7 multiplied by 1. Hang on, you got the same answer. No need to get into the ratio. That's how it is. Very, very simple and a very, very beautiful trick. So I repeat again. The denominator of the denominator is multiplied to the numerator of the numerator. Pardon me for my bad handwriting. I hope you're taking notes. Or go back, refer to this whiteboard when I share that in the chat, or go to the YouTube video and see the recording. And oh, you flipped them. Yes, that's right. Keep flip change. Keep change flip. Yeah, I think that's also anything that works. And the denominator of the numerator is timesing by the numerator of the denominator. That's it. That's the trick. As simple as that. All right. With that, let's move forward. I hope this made sense today. Let's maybe play with some fractions. Oh, sorry, some decimals as well. 2.1 ratio 3.5. Can you simplify that? All of you, I need to see the answer, please. Once. There's nothing called 3 over 10. 3 ratio 5 is the right answer. I don't know what technique did you use. So there are a few techniques that I can use. The first one is make them, if count the decimal places. So if you've got just one decimal place here and one decimal place here, decimal just cancels itself. So this actually becomes 21 ratio 35, which is 3 ratio 5, what you just calculated. The other way is actually converting this into a fraction, which is 2.1 becomes 21 over 10, and 3.5 becomes 35 over 10. And now, as I said, in the world of fractional ratios, the denominators are same, you can cancel them. And this becomes 21 ratio 35, which is 3 ratio 5. All right, let's do one more. Tell me what is 1.44 ratio 0.75. Go for it. 1.4 to 0.75. I haven't seen an answer yet. 1.1, Trisha, it's not 1:3, I think. No, Rhythm, it's 140/75. Rhythm, you can simplify that or further down. Try. 140:75 is fine. No, Chino, it's not 20:15. Yeah, the right answer is yes, correct, Karthik. It is, yeah, all of you who answered 28:15 is the right answer. Yes, 28:15 is the right answer. Now, how did we do it? Easy peasy. My way of doing it, probably I convert into a decimal first. Decimal to a fraction. So this becomes 75/100. Right. And then probably if I'm, then what do? I times this by 10. I times this by 10. Why? Because I want to make the denominator the same. So this becomes 140/100 ratio 75/100. So finally, 100 cancel. So I've got 140/75. And now I can just simplify them. They both can be divided by 5. The highest common factor is 5. So this becomes 28/15. All right, so we did the simplification of ratios for whole numbers. We did simplification of ratios for fractions. We did simplification for ratios for decimals. Let's do simplification of ratios for algebraic terms, right? My favorite topic, algebra. Now, and I'm assuming you know a lot about algebra by now. If I give you x squared ratio x squared y, can you give me the simplest form? One ratio y is the right answer. Not two ratio y, Khyati. All right, two ratio y raises me a concern. Let me just do it, right? All right, I think one of you actually knocked off x by x and saying uh, 2 ratio. I mean, this is not the way it has to be. So x square, so x square can be knocked off by x square by a 1. They're actually dividing, right? What is the, if I go back to the world of numbers, I have x square ratio x square y, which is the highest common factor. I can divide both of them. It's x square. That's the common factor between the two. So x square gone, x square gone. So you have 1 ratio y. Algebra makes it a bit more tricky. Let's do another one where we mix numbers and pronumerals together, right? 10a square b ratio 15ab square. Can I have the answer, please? Two A three B, 2A3B. All right. Sounds right to me. Anyone who don't know how to do this, just say no. I want to see how many don't know, and then probably I'll just sort of explain it in that fashion, more detailed fashion. All right. Okay. We've got a couple of them who don't know. That's okay. Now, what is the common factor between these two? If I may ask you, what is the common factor between these two? AB is fine. What about the number? You've got a number as well, Kathy. 5. So 5 from numbers and AB from the alphabets or from the variables. Right? So that is the common factor. So I'm just going to divide 5AB on both the sides. So it essentially means 5 times 1 and 5 times 2. 1A goes, takes away 1A. 1B gone takes away 1B. They're all 1 basically. They're all multiplying by 1. Gone does not mean 0. Okay, remember that. And on the other hand, 5 times 1 and 5 times 3. And now, yes, you got it right, Khyati, this time. And A gone. So you've got 2A ratio 3B. Absolutely right. That's the answer. So when it comes to algebraic terms, it becomes slightly more complicated, as in the workload, it's not complicated. The workload slightly increases. You're dealing with variables. You're trying to find the common factor of variables. And you've got numbers as well, right? Both of them. I hope everyone's clear on this one, right? We'll do one more. So I have now 36 m cube n square ratio 48 m square n square. Can I have the answer, please? Three m ratio 4 is what I'm hearing. Anyone who hasn't got this? 3m ratio 4 is what I'm hearing, is I'm looking, right? 3m, not 3m ratio 4m Satvik, it is 3m ratio 4. The m's gone. I'll do one more. I'll do this one, probably. Anyone who hasn't got this, can I see a no from anyone who hasn't got this? Looks like all of you are fine. So how do we do this? 36 and 48. I've got 12 as the common factor. Correct. Correct. So 12 times 1 and 12 times 3 and 12 times 1 and 12 times 4. Between m cube and m square is the common factor. So m square here, m square here. So square takes away two m's at the top. So it just remains with one m only. Whereas m square takes away the whole m square on the right hand side. And lastly, the n square and n square, that's n square, that's common between both of them. So n square gone, n square gone. So when I'm saying gone, that means one. They're all one. They're all multiplying, right? They're not zero, please. So what have I left with? I've left with a 3 and a 4, and I've left with just one m. So the answer is, I think most of you have just given that answer, which is 3m ratio 4. That is the answer. All right, cool. That was a bit about ratios. Now extend this to, and you've got like 10 more minutes to go. I extend this to the next step once you've understood ratios is called proportions. And we'll do a few proportions before we wrap this session off today. Now, what are proportions? Proportions is a statement of equality of two ratios. So when you equate two ratios, it becomes a proportion. When you equate two ratios. So let's do that. So for example, if I am equating, let us say A ratio B equals to equating. So that is equal to sign. It's an equation of ratios. It's another way of equation of ratios. Equation of ratios. And I'm equating this to C ratio D. So two completely different ratios being equated together with an equal to sign in between. Now, I told you that ratios are fractions. So I can say this as A over B equals to C over D. And hence, when you have this kind of a scenario, and I think I did explain that long time back when we were doing linear equations, if I remember correctly. So when you've got two fractions which are sitting against each other with an equal to sign, you can simply cross multiply. Cross multiply. Cross product. So A times D is equals to B times C. So AD is equals to BC. That is the final outcome of your proportion. They have to be equal. So the rule is, if two ratios are equal, then this has to hold true. This has to hold true, the cross multiplication. Now, this cross multiplication helps us solve a lot of algebraical problems. So if I now have A ratio 3 equals to 6 ratio 9, and I ask you, can you find the value of A? Can you do that using cross multiplication now? A is 2, absolutely right. Now, how did we do it? First of all, quickly convert them into a fraction, please? So that means a over 3 equals to 6 over 9. And then my wonderful cross multiplication works. So I can say 9a equals to 6 times 3 is 18. I divide 9 by both the sides. To get rid of this 9 here, which means a is 2. A is 2. Okay, let me take a snippy of one of the questions. See, whether we can do it or not. All right, here you go. Can you try this question, please? "21 is the right answer. 21 boys. Always remember, when you are solving, this is especially for your school exams, right? You're all high school kids now, especially for your school exams. Whenever you are given a worded problem and you're asked, and I just time and again, I just keep repeating this stuff. Whenever you have worded problems and you're asked specific things, just don't say the number. Apply the unit. Here the unit is boys. 21 boys. How did we do it? My ratio was 4:3 between girls. So the ratio is girls to boys. So girls to boys. 4:3 equals to, again, you have to maintain the same order. You cannot have boys to girls now. So you have girls to boys here. Girls are 28, and let's say boys are B. That's what we are after. So we've got 4/3 equals 28 over B. Cross multiply. 4B equals to 28 times 3, which is 84. No need to write it. So 28 times 3 divided by 4 is 21 boys. All right. Let's maybe do one more. All right. Okay. Just trying to find something really tricky for you. Just give me a second. All right, let's try this one. Yeah, this is a good question. Let's do this one. Last question of the day, guys. Probably, not sure you can see this. Yeah, I think you should. Go for it now. Take your time. All right. So it says determine how much the other two children receive. Other two children receive. So I need two answers, right? So the first one received 32. How much the second one and the third child received? So it is, yes, 28 and $20. All right. So they're given, the three children are given the allowances in the ratios of their ages, 16, 14, and 10. 16, 14 and 10. 16, 14 and 10. What's the simplified version of this? Now, ratios can also be three-step, right? So if this one receives 32, how do I make it 32? Times 2. How do I make, so if this is times 2, this has to be times 2, this has to be times 2. So I'm just making them equivalent. So 28 and 32, 28. All right, with that, I stop my lesson here today. I finish my lesson today here, and I will see you back next week. Now, mind you, there are only two more lessons to go. You've got your selective school exam on the 20th, I think, of uh, the coming month. So practically, we've got just two more lessons to go, right? I'll see what I'll do, right? Thank you very much for your time. And last but not one more thing, if you are a part of WhatsApp group, every day there are questions being given in that group, right? So if you want to practice, feel free to. Thank you very much. Enjoy your rest of your Sunday. Goodbye.